Maths learner. It's Ruby Gupta again. Welcome to my channel. Today we are going to learn about the rational numbers. In this coming video, we are going to cover classification of a numbers, basic concepts of the rational number, example based on the classification of a number, operations on the rational number, word problem, and try and learn together. Then we are going to find out the rational numbers between the two rational numbers, converting repeating decimals into the fraction, or you can say writing down the rational representation of a repeating decimals. Let's get started. Set of a real number is all numbers that can be written on the number line. Remember, every number is a real number. The numbers are divided into two categories, which is rational number, irrational number. Rational number contains integer, whole number, natural numbers. Now, natural numbers are the counting numbers 1, 2, 3, 4, 5, and moving onwards. Whole numbers contain 0 along with the natural number, or you can say 0, 1, 2, 3, 4, 5, moving onwards. Integers are the whole numbers and along with the positive and negative signs, for which I already uploaded the video and you can refer that for the various operations on the integers along with that. Now, what are the rational numbers? The basic definition is given as the any number that you can write it down in the fraction form where denominator should not be equal to 0. Along with that, they could be repeating decimal in the pattern, terminating decimals, all are the example of the rational numbers. Now, if these are all rational numbers, the question comes, what are their rational numbers? All the non-perfect square roots, perfect cube roots, or the numbers without any pattern are repeating their irrational number. For example, pi, easiest of all. It's keep on repeating and we never know where it will end. Cube root of 2, cube root of 4, they all are irrational numbers. Now guess what? 0 is a rational or irrational? 0 is a rational number because 0 you can write it down 0 divided by 1, 0 divided by 2 because the condition says only denominator should not be equal to 0. So 0 is a rational number. Let's solve these questions together and figure out which category these number belongs to. Square root of 4. Square root of 4 is 2. So it's a rational, whole, natural integer. Square root of 8, which is not a perfect square. So I mentioned, so it's an irrational number. Cube root of 8, it's 2. So it's rational, whole, natural integer. Cube root of 16 is irrational because it's not a perfect cube. 0 by 3 is 0, which is a rational number. So it is integer as well as whole. It's not natural. Now let's understand the operations on the rational numbers. The way to add the rational number is same as the integer. Same sign add, different sign subtract. The only thing is here we need to deal with the fractions or the decimals. So if I have 2 6 plus 3 6, as I shown on the screen, it is 5 6. Negative 2 6, negative 3 6 is negative 5 6. So we have to do the same way. Another thing to make it easier, you can convert mixed fraction into the improper fraction and perform the desired given operations. How to multiply? For example, let's say you have to do negative 13 by 2 times 9 fifths. To multiply the rational numbers numerator to numerator, denominator to denominator, negative 13 times 9 is negative 117, 2 times 5 is 10. So it's a negative 117 over 10, which is equal to negative 11 whole 7 tenths. Now take a pause and you try your own. Negative 6 wholes 1 half times 1 whole 4 fifths. Message your answer in my comment box below. Understand the divisions of the rational numbers. First step that you need to do, convert mixed fraction into the improper fraction. That makes our work easy. Apply the key flip change that we use to do the division of the fractions and apply the normal multiplication of a fraction or the decimals. So for example, you have to do negative 12 divided by 1/3. So you have to keep negative 12 as it is. Convert division into multiplication and flip the 1/3. The 1/3 would be converted into 3 ones, which should be equal to negative whole 36. Let's another example, negative 8 divided by 1 whole 3 fourths. So convert mixed fractions into the improper fraction, which will give you negative 8 whole divided by 7 fourths. Now convert this division into multiplication and flip the 7 fourths into 4 sevenths. Then that will give you negative 32 sevenths. Here are the few word problems to try on your own. Michael needs 6.5 feet of metal flashing to complete a household project. He has two small pieces measuring 3 holes 1/8 feet and 1 hole 3/4 feet. How many feet of metal flashing does Michael needs to purchase? So think what operation you would to need to do and do is a normal way because these are just a positive number, no negatives are there. Mikey signs up for a cell phone plan that his parents require him to pay for. His bill each month is $45.20. What impact will his cell phone bill have on his saving accounts over the period of a year? Here is you need to think whether his account balance will increase or decrease. Let me know your answer in the comments below. Here are the few more problems. Remember when we are doing this type of operation, we still need to follow the PEMDAS. P stands for parentheses, E stands for exponent, M for multiplication, D for division, A is for addition, S for subtraction. So first one, let's say we are doing minus 4 minus 3 divided by 7. So we have to solve for parentheses. So minus 4 minus 3 is minus 7. Minus 7 divided by 7 is minus 1. Take a pause and you try it on your own. Here are the another few more examples to do so. Let me explain what this table means. You have to do A, B, a value of A is given to you, value of B is given to you. What will be the minus A, or you can think of opposite of A. So for example, here minus half, then opposite of minus half would be positive half. Opposite of half would be minus half. Opposite of minus 6 would be positive 6. For minus 4b, you need to do negative 4 times whatever the given values of b. Fill in those columns, please. Minus a plus b, you have to add opposite of a and b together and write down. Remember, don't forget to perform your integer or rational number operations. Let's solve together. How to find out a rational number between the two given rational numbers? While there are the various ways by doing guess and check, but there's a certain foolproof method to do so. So the only thing is you have to calculate the midpoint of these two numbers and start working on it. So to calculate the midpoint, we have to do add these two numbers divided by 2. So first I did 1/4 plus 1/5, which is 9/20th. Then I divided by 2, which will give me 9/40th, which is keep flip change. So one number is 9/40th. And then again, you can just squeeze in, and you will get infinitely many numbers as you want. So I try to figure out one more number. 1/4 plus 9/20th is equal to, I have to make a same base. So which is equal to 5/20th plus 9/20th, which is equal to 14/20th. Reduce it to the lowest form, which is 7/10th. So it's another number I have. So keep on doing and you will have various numbers. Here is a one tip, not tip, actually a question. You can take 1/5 instead of 1/4 as well. Can we or can we not? Let me know your answer, please. Here are the few problems to try on your own. Few more word problems. Let's try the second one. On Monday, Karen had $22.50 in her bank account. She then withdrew another $75 on the Tuesday to pay her phone bill. Friday, she deposited $40.30. What is her current account balance? So you can write down the number sentence as a $22.50 minus $75 plus $40.30. Use rational number or integers operations and let me know your answer. Now, we will convert repeating decimals into fractions. But before moving on, let's know your instructor. Myself, Ruby Gupta, and I have cleared my MSc and MPhil in Math and MPhil for secondary mathematics from USA. Currently, I'm living in USA and I'm an independent tutor last 8 years. So, coming back to this, converting repeating decimals into fractions. What are the repeating decimals? Repeating decimals are the decimal where certain digits are repeating in certain pattern. Remember, we can convert repeating decimal into fraction where they are repeating in patterns. If they are not in pattern, they are irrational number. We cannot do anything. For example, 0.89 repeating. The bar over the number represents that these digits are repeating. For 2, 0.78. Here is a, you can think of 0.78888 keeps on going. Now, here are the steps to solve converting repeating decimals into the fractions. Set the given decimal equal to x as an equation. Second, multiply both sides by 10 raised to the power, which is a number of digits in the repeating pattern. Let's say if after decimal one digit is repeating, you will multiply by 10 to the 1, which is 10. If two digits are repeating, then you will multiply by 10 to the power 2, which is 100, and so on. Then you subtract the second equation from the first equation, and boom, here is your solution. Let's solve the equation and see how it works. I have to convert 1.5 repeating into the fraction. As I mentioned the step, x is equal to 1.555 keeps on going. Second step, here only one digit is repeating, so I need to multiply by 10 to the power 1, which is 10, which I did. So 10x is equal to 15.555 keeps on going. Then I need to subtract second equation from the first. Then I have 9x is equal to 14.0. Take a pause and see how it is working. At the end, I have 9x is equal to 14. Then x is equal to 14 divided by 9. You can check in the calculator. 14 divided by 9 is 1.5 repeating. Let's try another problem. Here the three digits are repeating. 0.123 repeating. So you can think of 0.123, 123, 123, 123. After decimal, three digits are repeating. So I need to multiply by 10 to the power 3, which is 1000. So 1000x is equal to 123.123, 123, so on. I subtract my initial equation from the second equation, which will give me 999x is equal to 123. Now I solve for x. 123 over 999. Remember, don't forget to reduce it to the lowest form. You need to know. So I just divide by 3. 143 divided by 3 is 41. 999 divided by 3 is 333. This is your answer. Here are the few problems to you to try on. Here are the few more examples I added here. It is the same way you can try it on. Here is a different type of example where after decimal only one digit is repeating. It is also the same way you can work on. Another thing, keep it into mind when you're writing down the fractions, try not to have decimals in your fractions to get rid of those decimals. Either multiply by 10, 100, whatever is needed. Practice time. These are the few problems. Try on your own and let me answer you in your comments. Thank you.